Chapter 2.7 is systems of linear equations in two variables. So far we've already solved linear equations with one variable. Now we're going to have two equations, each with two variables in them. So this is called a system of linear equations when there's two or more linear equations. And we're going to be solving for x and y. And the x and y that we solve for is going to represent the xy ordered pair where the graphs intersect. So for example, let's determine if each one of these ordered pairs is a solution to the system. So we have x plus 2y equals 2 and x minus 2y equals 6. So we use the squiggly bracket, the brace, to represent a system of linear equations. So what we're going to do is we're going to plug in for this first one for a. We're going to plug in 4, -1 into each one to see if it works for each one of those equations. So starting with the first one here, we have x plus 2y equals 2, and we're given an xy coordinate, so we plug 4 into x and -1 into y. So it's going to be 4 plus 2 times -1 equals 2. And that's going to be 4 minus 2 equals 2, and we get 2 equals 2. So that's obviously true, so that one works out. And we're going to test it for the other one also. X minus 2y equals 6. We're going to plug in a 4 and -1 once again. And that gives us 4 plus 2 equals 6. And this one is also true. We get 6 equals 6. So that gives us that this ordered pair is a solution. So let's try it for -4, 3. So we're going to plug in -4 into x for this first one, and then 3 into y. So -4 plus 2 times 3 equals 2. So this gives us -4 plus 6 equals 2, and this gives us 2 equals 2, so that one works out. Then we check the other one, x minus 2y equals 6. We plug in our values, -4 minus 2 times 3 equals 6. That's -4 minus 6 equals 6. This one is -10 equals 6, which is not true. So that means this ordered pair, -4, 3, is not a solution. So we can actually graph these. We can graph these two equations that we started with. If we wanted to, we could solve them both for y, put them in y equals mx plus b form, or we can plug in points for x and then get out its y coordinate and graph it. So I'll just graph them though really quickly. So these would be both of the graphs if we graphed them, and we can see that right here where they intersect at 4, -1. And we said from part A that was the solution, and we can see graphically that that is the solution to these two systems. So graphically speaking, the solution is where they intersect. Okay, so we're going to be solving these by hand. So there's two main ways that we solve these. They're going to be the substitution method and the addition method. So solving these meaning we're solving for x and solving for y. So starting with the substitution method here, what we're going to do first is we're going to solve one of the equations for one of the variables. So you can solve for whichever variable you want, but there's usually going to be an easiest one to solve for, which we'll see in a second. And once we solve for one of the variables, we're going to substitute that expression into the other equation's variable, hence the name substitution method. Then we're going to be left with one equation, one variable, so we can solve for that variable. And then we need to substitute that value back into the equation from step 1 to find the other variable. Okay, so let's see what that means so it makes a little bit more sense here. So we're going to solve this with the substitution method. We have the system 5x minus 4y equals 9 and x minus 2y equals -3. So finding the x and y that satisfies both of these equations. So we want to pick one of these variables to solve for. We can either solve for this x, this y, or this x or that y. The easiest one to solve for, in my opinion here, is going to be this x right here. So if we solve that for x, starting with x minus 2y equals negative 3, we would have to add 2y to both sides. We would get x equals 2y minus 3, and then we're going to take this and substitute it into the x in the other equation. So looking at the other equation here, we have 5x minus 4y equals 9. And now we're going to substitute 2y minus 3 into x. So it becomes 5 times 2y minus 3 minus 4y equals 9. And now we have one equation, one variable, and we can solve it for this y now. So we have to distribute the 5. So we're going to get 10y minus 15 minus 4y equals 9. And combine like terms on the left, we get 6y minus 15 equals 9. Add 15 to both sides, 6y equals 24. Divide both sides by 6, we get y equals 4. Okay, so that is one of our answers here. Now we're going to plug this back in. We're going to plug this back into all the way up here into y to solve for x. So that's why the substitution method is really nice, because we already have the other variable solved for, so we just have to plug it back in. So plugging in a 4, we get x equals 2 times 4 minus 3. That's x equals 8 minus 3, so that gives us x equals 5. So you could just circle both of those answers. We have x equals 5 and y equals 4. Or we can write it as an xy coordinate as 5, 4. Okay, so graphically speaking, I'm just going to graph these two equations real quick, and then we can see that this is the solution. So when we graph them, we get these two graphs, and we see that they intersect right here, and we can also see that the coordinate is 5, 4, which is our answer. Okay, so let's do another one here. So we have 3x plus 2y equals 4 and 2x plus y equals 1. So we want to pick which variable to solve for. I think this variable is going to be the easiest to solve for once again, because there is a coefficient of 1 on it, so we won't have to divide by anything to get the y by itself. So solving for y from 2x plus y equals 1, we have to subtract 2x on both sides, so we get y equals 1 minus 2x. And now we're going to take this and plug into the other equation into the y. So we're going to take that and plug it into this y in the other equation. So starting with 3x plus 2y equals 4, plugging in for y, it becomes 3x plus 2 times 1 minus 2x equals 4. Now we have one equation, one variable, so we can solve for x. First we have to distribute the 2, so we get 3x plus 2 minus 4x equals 4. And combine like terms on the left, 3x minus 4x gives us negative x, so negative x plus 2 equals 4. Subtract 2 on both sides, negative x equals 4 minus 2. So 2, and then we have to divide or multiply both sides by negative 1. That gives us x equals negative 2. So now we're going to have to solve for y by plugging back into right here. So plugging that in, we're going to do y equals 1 minus 2x. So y equals 1 minus 2 times negative 2, which is 1 plus 4. So we get y equals 5. So once again, as an xy coordinate, we could write this as negative 2, 5. And you could always check your answers if you want. You could plug them back in the original ones. Plug negative 2 for x back in, and plug 5 in for y, and make sure it works for both of them. Okay, let's do one more for substitution method. So we have 2x equals 3y plus 4, and 4x equals 3 minus 5y. So for determining what to solve for, I'm going to, first recognize that all of these variables have a coefficient other than 1 on them, so it's going to be a little bit messy no matter what. But I think it's going to be the easiest to solve this one for x because it's almost solved for. We just have to divide everything by 2. Okay, so like I just said, we have to divide everything by 2. So that's going to be x equals 3 divided by 2 plus 4 divided by 2 is 2. So we get x equals 3/2 times y plus 2. And we're going to take this and we're going to plug it in the x in the other equation. So we have the equation 4x equals 3 minus 5y. And we're going to plug in for x, so it becomes 4 times 3 over 2 times y plus 2 equals 3 minus 5y. And now we have one equation, one variable, so we can solve this for y. So on the left-hand side of the equal sign, we have to distribute the 4. 4 times 3 over 2, that's 12 over 2, which is 6. 6y plus 4 times 2 is 8. So let's get all of the variables on the left and all the constants on the right. So I'm going to add 5y to both sides. And we're going to subtract 8 on both sides. So 6y plus 5y is 11y. 3 minus 8 is negative 5. So we get y equals negative 5 over 11. And we're going to take this and plug it into what we had up here. Plug into x equals 3/2 y plus 2, and we're going to do that to find the x value. So it's going to be x equals 3/2 x, or 3/2 y plus 2. So plugging in negative 5 over 11. So we're dealing with fractions, so hopefully we're all good with that. So 3/2 times negative 5 over 11, that's going to give us negative 15 over 22 plus the 2. So getting common denominators here, that would have to be negative 15 over 22 plus 44 over 22. So we had to rewrite 2 as 44 over 22 by multiplying the numerator and denominator by 22. And now we just subtract negative, or add negative 15 plus 44, or 44 minus 15. We get 29 over 22 for x, and that's all we have to do. So the coordinate, those are our two answers. The x coordinate is 29 over 22, and the y coordinate is negative 5 over 11. So the next method to solve these is going to be the addition method. So the addition method is going to be exactly what it sounds like. We're going to be adding the equations together with the end result being that we want to eliminate one of the variables. So we're going to add the equations together. One of the variables is going to be eliminated, and then that'll allow us to solve for the remaining variable. So the steps for this is going to be rewrite both of the equations in the form ax plus by equals c. So x first, y second, constant on the right hand side. And for step 2, we may not have to do this, but we might have to do it. So for step 2, we might have to multiply one or both of the equations by a number so that the sum of the coefficients on x or y is 0. So your goal is to add the equations and have one variable cancel. So you're going to have to multiply by a number so that when you add them together, they do cancel. Next, you're going to add the equations. The sum is going to be an equation with one variable. You're going to solve for that variable and then substitute that variable back in to one of the originals to find the other one. So let's do an example here. So we have the system x plus 2y equals 7 and negative x plus y equals 2. So our goal here is to add these together and get one of the variables to cancel. So we don't need to change any of these equations because if we add these right now, the variable for x will cancel because x plus negative x will give us 0x, so those ones will cancel. Okay, so if we add these together, that's going to be x plus 2y equals 7 plus negative x plus y equals 2. And we're going to add them up. So you add them right down the column. So they're both in the proper form. We have the x and then the y equals the constant. So we add them down. The x's cancel. And we're left with 2y plus y is 3y. 7 plus 2 gives us 9. So now we have this equation 3y equals 9. And then all we have to do is solve that. Divide both sides by 3. We get y equals 9 divided by 3, so that's y equals 3. So now we're going to take this value and plug it back into one of the originals to find the x value. So it doesn't matter which one we plug in. I'm just going to plug into the first one. So that's going to be x plus 2y equals 7. Let's plug in y equals 3. So that's x plus 2 times 3 equals 7. Which gives us x plus 6 equals 7. Subtract 6 on both sides. 7 minus 6, we get x equals 1. So this gives us the ordered pair, x equals 1 and y equals 3. Once again, you could check these if you want by plugging them back in the original. Okay, and then the next one here. We have 3x plus 2y equals 48 and 9x minus 8y equals negative 24. So we have this in the proper form. We have x and then y equals the constant. But if we try to add these together right now, the x's are not going to cancel and neither will the y's. So we get to choose which one we want to cancel. And it really doesn't matter at all. I'm going to choose to cancel the x's. So in order to cancel the x's, when we add them up, we want them to cancel. We need to multiply this first equation by negative 3. Okay, so when we multiply this one by negative 3, that's going to give us a coefficient of negative 9 on the x variable. So let's multiply everything by negative 3 in that first equation. So we're going to have negative 9x minus 6y. 48 times negative 3 gives us negative 144. So I'm just going to write the second equation below it now. So with that negative 9 on the x variable, now when we add these together, the x's are going to cancel. So we had to pick whatever we had to in order for the x's to cancel. So negative 9 plus 9 is 0. They cancel off. Now we're going to have one equation with one variable. We have negative 6 plus negative 8. So we get negative 14y equals negative 144 plus negative 24 is negative 168. Divide both sides here by negative 14. We get negative 168 divided by negative 14. We get y equals 12. And now we're going to take this and plug it back into one of the original equations to find x. Okay, so it doesn't matter what one we choose to plug into, just plug it into one of the original equations. I'll choose the first equation, so that's going to be 3x plus 2y equals 48. And plug in y equals 12 and solve this for x. So 3x plus 2 times 12 equals 48. That's going to give us 3x plus 24 equals 48. Subtract 24 on both sides. 48 minus 24 is 24. Divide both sides by 3. We get x equals 24 divided by 3, so we get x equals 8. So this gives us the ordered pair, 8, 12. Okay, so let's do a couple more here. 2 more probably. Yeah, 2 more to make sure we're good. So next one, we have 3x equals 8 minus 4y. And 4y equals negative x minus 4. So before we do anything, the first thing we have to do here is write this in the correct form. So we need to get this y on the left-hand side and this x on the left-hand side. So we're going to add 4y to the left. So 3x plus 4y equals 8. And then for the bottom one, we have to add x to the left. So we get positive x plus 4y equals negative 4. So just rewriting it to get it in the proper form. And let's get the y's to cancel here, because if we get the y's to cancel, all we have to do is multiply one of the equations by negative 1. So I'm just going to multiply this equation by negative 1. And that will give us y variables. The y variables will cancel after we add them now. So let's just rewrite this first one. So it's 3x plus 4y equals 8. We didn't change that one. Next one, we multiply everything by negative 1. That gives us negative x minus 4y equals positive 4. And now we're going to add down the columns. We know that the y's are going to cancel, 4 minus 4. 3x minus x gives us 2x. 8 plus 4 gives us 12. So we get 2x equals 12. Divide both sides by 2. We get x equals 6. Okay, so now we're going to take that and plug this back into one of the originals to find y. And let's plug it into this second equation because y is already almost solved for. So let me write that down. So it's going to be 4y equals negative x minus 4. No matter which one you choose to plug in, it should give you the same answer. So plugging in x equals positive 6 here, it's going to be 4y equals negative 6 minus 4. That's 4y equals negative 10. Divide both sides by 4. We get negative 10 divided by 4, which simplifies to negative 5 over 2. Okay, so both of our answers here, that's going to be 6 for x and negative 5 over 2 for y. Now let's do one more and then we'll get into the special cases, 2 examples of special cases. So we have 2x equals 7y minus 17 and 5y equals 17 minus 3x. So first we have to get this in the correct form. So it's going to be, we need to get 7y to the left, so we have to subtract 7y, so that's 2x minus 7y equals negative 17, and then we need to add 3x to the right, or we need to add 3x to the left for the second one, so we get 3x plus 5y equals 17, and now we needed to decide which one we want to cancel. So for both of these, no matter which one we choose, x or y, we're going to have to multiply both equations by a number here, because one of the coefficients is not a multiple of the other coefficients. So let's choose the x's here. Let's cancel the x variables. So we have 2 and 3. So we need to think of their least common multiple, which would be 6. So in order to get a 6 coefficient on the first one, we're going to have to multiply this whole thing by 3 for the first equation to get that to be a 6. For the second one, we would have to multiply the second one by 2 to get a coefficient of 6. But let's multiply this by negative 2. So one of them's positive, one of them's negative. So when we add them up, they cancel. So we could have chosen to cancel y, but the numbers would have just been a little bit bigger, which is technically fine. So let's multiply that first equation by 3. We end up getting 6x minus 21y equals negative 51. Multiply the second equation by negative 2. We get negative 6x minus 10y equals negative 34. And now we're going to add these up. And we add these up knowing that these x's are going to cancel because that's why we did it. So negative 21 plus negative 10 is going to be negative 31y. Negative 51 plus negative 34, we get negative 85. Divide both sides by negative 31. The negatives are going to cancel. Negative divided by a negative is a positive. We get 85 over 31, and I don't believe that's going to simplify. So now we're going to take this and plug it back into one of the originals to solve for x. So let's choose the first equation here to plug it in because x is almost solved for. So we're going to be plugging this into 2x equals 7y minus 17. And plugging in y here, we get 2x equals 7 times 85 over 31 minus 17. So this one kind of stinks because we have this large fraction in here. So multiplying 7 times 85 over 31. So 7 times 85 is going to be 595 over 31 minus 17. So now we would have to get common denominators here on the right. So getting a common denominator of 31. 17 rewritten so it has a denominator of 31 would be 527 over 31 because that would be multiplying 17 over 1 by 31 over 31. And now we can combine this. On the right, it would be 595 minus 527, which gives us 68 over 31. And now we're getting a little bit closer to being done here. Divide both sides by 2. When you divide both sides by 2 here, it's going to end up being 68 over 31 divided by 2. This would be keep, change, flip. You keep the first one the same, change to multiplication, reciprocate 2. So instead of dividing by 2, we can multiply by 1/2. That would give us 68 divided by 31 times 2. So 68 over 62 would give us 34 over 31 after we simplify it by a common factor of 2. And that would be as far as it goes. So that's going to give us the solution set. 34 over 31 for x and 85 over 31 for y. So a little bit messier that time, but still pretty doable. So up until this point, all of these examples that we've done had one solution. It had one ordered pair. That is one of the options. The other two options of what can happen, we can have no solutions or infinitely many solutions. So if we, graphically speaking, if we have one solution means that the lines intersect at that point, which we already know. We've already shown that graphically. If we have no solutions, that means the lines are parallel. So you can see right here, if the lines are parallel, they're never going to intersect each other, so there would be no solution. The third option is there's infinitely many solutions. If there's infinitely many solutions, that means the lines are identical, which means they're the same line, so they would just be right on top of each other. So technically, there's an infinite amount of solutions. Okay, so let's do the one with no solution first, so we know how to recognize that it's no solution when we're doing it by hand. So when we have a linear system with no solution, we call this an inconsistent system. When we are solving this using whatever method, what's going to happen is that the variables are going to both be gone. So both variables will cancel off, and then you will have a false statement resulting. So you're going to have the variables cancel and have something like 0 equals 2. So that's not true, so we know there would be no solutions. So let's see an example of this. So we have 4x plus 6y equals 12 and 6x plus 9y equals 12. So let's decide to cancel the x variable. So to cancel x, we would have to multiply this by 3. We are trying to get the coefficients to be 12 because that's the least common multiple of 4 and 6. So we would have to multiply the second one by 2, but let's multiply it by -2 so that they're opposite signs, so when we add them they cancel. So okay, so we're doing this to cancel the x. So our new equations that we're having that are equivalent, multiply that first one by 3, we get 12x plus 18y equals 36. Multiply the second one by -2, that's -12x minus 18y equals -24. Now we're going to add these up. So when we add these up, we expected the x's to cancel, but the y's also cancel. We have 18 minus 18. So we're left with 0 on the left. 36 plus -24, 36 minus 24 is 12. So we're left with 0 equals 12. So we can see that the variables cancel and we got a false statement. 0 does not equal 12. That means there are no solutions here. So no matter what values we plug in, no xy ordered pair will satisfy both of these equations simultaneously. So graphically speaking, if we were to graph these, we would see that they are parallel lines and they will never intersect. We could solve these both for y, get them in y equals mx plus b form, and we would see that they have the same slope with a different y-intercept. Okay, so one more thing here, linear systems with infinitely many solutions. So one with infinitely many solutions is called a dependent system. So if we solved both of these equations for y, they would actually be the same exact equation. So if we tried doing this with the substitution or addition method once again, what we would do is the variables would eliminate again. So the variables would cancel just like they did in the previous one, except this time we would get a true statement. So this time we would get something like 0 equals 0, and that's how we know that there's infinitely many solutions. So let's see this example, and let's do this one using the addition method once again. So if we're doing the addition method here, we have y equals 3x minus 2 and 15x minus 5y equals 10. So the addition method, we need to rewrite this to get the x on the left-hand side for the first one. We have to subtract 3x to the left. So we get negative 3x plus y equals -2. The second one is completely fine. And then we have to decide what we want to cancel. Let's say we want to cancel the x variable. So if we want to cancel the x variable, we would multiply the first equation by 5 because that would give us a coefficient of -15. So when we would add them together, it would cancel the x's. So let's rewrite this with that being multiplied by 5. So we get -15x plus 5y equals -10. And the second equation, we didn't have to adjust that one, so we just rewrite it. Okay, and then we're going to add these together. And then we see that the x's cancel off because that's what we wanted to happen. But then we notice that the y's are also going to cancel. 5y minus 5y, so we get 0. On the right hand side, -10 plus 10, that also gives us 0. So this time both of the variables canceled and we got a true statement, so there's infinitely many solutions. So if we solved both of these equations for y and got them in y equals mx plus b form, they would be the same exact thing, so there's infinitely many solutions. So for graphically, let's say we graph them. So if we graphed them, it would look like that, where they are just directly on top of each other. So obviously there's an infinite amount of solutions. No matter where we are in that line, it's going to be a solution to both of the equations because they are the same. Okay, so that is it for 2.7.